Hello everyone and welcome back to another episode of Better Together at Math with Shinrai Sensei. And today we will be going into angles, right? And angles, as I wrote in the red here, are a figure formed by two rays with the same endpoint. And that same endpoint is what we call a vertex. The point that forms the angle, right? That is what we call the vertex. Since let's go ahead and use this example, right? We have ray AB and we have ray AC, and since they both share the endpoint A, then A is the vertex, right? So A is the vertex, and then each side is either ray AC or ray AB. Okay? Very simple. We're not going to worry about it, but for future reference, you will be able to measure the angles with a tool that we call a protractor, right? And then you just set it on one of the two sides. You set the protractor completely flush with it, and then where the other side lines up on the protractor should tell you what the angle measurement is, right? But the measurement of the angle is not so much important today. We're just getting into some basics, okay? So the next factor to know is what different angles there are. So you have an acute angle, an obtuse angle, a right angle, and a straight angle. And as shown here, 0 to 89 degrees. And by the way, yes, I know that it's not technically 89 degrees. Even it would be 89 plus 9 repeating for infinity degrees, right? And same with these obtuse angles. So it actually would be 91 to 179.9 repeating for infinity degrees here. But a right angle is specifically 90 degrees, and a straight angle is specifically 180 degrees. Right, 100%. That is what right and straight mean. Right? Now, this example is going to become relevant that I've drawn here when it comes to talking about this next phenomenon. So adjacent angles. You have a common vertex and a common side, but there is no common interior points. So some adjacent angles here would be angle EDG and angle EGF would be two adjacent angles, right? They share a side and a vertex, but they do not share interior points. So if I was to draw a point on the inside of this angle, right? So I take this purple marker and I draw points in here, right? And I have this point is 1, 2, 3, 4, right? Angle EDG here has points 1 and 2, but angle EGF has points 3 and 4 within it. These will never overlap, and that's where the no common interior points comes from for adjacent angles. The points 3 and 4 can never suddenly populate in this angle because they exist in this angle. And same with points 1 and 2 can never populate over here because they're already over here. It's common sense on that respect, but it's just so you know that these angles are different even if they share a whole side and their vertex. They are different, right? But that doesn't change the fact that angle EDG and angle EGF are, sorry, let me close that A off, congruent, right? That fact does not change because 1 and 2 don't go into 3 and 4. In fact, it's reinforced by that, right? Or not, congruent, sorry. They are, that was my mistake. They are adjacent. Congruent angles don't need to share any information. If I was to, say that and this is just for hypothetical purposes, this is not actually talking about the accuracy of these angles, right? But if I was to say that this is 30 degrees and this is 30 degrees, right? Then angle ABC and angle EDG are congruent, right? And feel free to take a screenshot at any point in time if you guys need to. I'm sorry this got kind of messy. I started to run out of room on the board here for some of this information, but the angles just have to have the same measurement. They don't have to share any other information. They just have to share that measure, right? And then an angle bisector would be, let's say that this is also 30 degrees for hypothetical's sake, you know. Let's say that's also 30 degrees there. Well, then the angle bisector for EDF would be ray EG, because it's a ray dividing an angle in half. So ray, or it should be really ray or line segment, right? But ray EG is what it's going to want us to call it, even though it's not a ray. EG bisects angle EDF, right? Because both sides of this are measuring the same angle, right? So those are the basics of angles, and like I said, we'll work on getting into some postulates and theorems specifically regarding angles inside of shapes in some episodes coming up. But this was just to introduce you to angles and some more basics of geometry. Please, I will stand off to the side here for a minute or two so that you guys can copy the board, or you guys can just take a screenshot for your notes purposes. And I will go ahead and close off the episode over here. But thank you guys for watching. If you do have any comments or concerns or questions, please feel free to leave them in the comment section below. Or leave them at my Twitter handle, ShinraiSensei15, right? Or X, or whatever it's supposed to be called now. Just go ahead and follow me there. Post any comments or concerns or questions to there, or just leave them in the comment section here. But I look forward to seeing you guys in the next one, and I hope you guys are getting your screenshot that you need now. And if you guys have gotten your screenshots, then I hope you guys see me in the next one, and I hope to see you there too. Peace.